This is Dr. Keith Miller, and welcome to another hands-on video on mineral properties. In this particular video, we will be looking at the property of mineral hardness. The hardness of a mineral is a measure of how easily a mineral scratches or can be scratched by another material. When a mineral is scratched, atoms are being torn from the crystal structure of that mineral. You are breaking chemical bonds. So a mineral that has stronger chemical bonds between the atoms in its crystal structure will have a higher hardness. In the 1800s, a mineralogist by the name of Frederick Mohs created a relative mineral hardness scale using 10 relatively common minerals. These 10 minerals were ordered from the softest, talc, with a hardness of 1, to the hardest, diamond, with a hardness of 10. Now, the way Mohs scale works is that a mineral that's higher on the scale will be able to scratch one lower on the scale. So here we're looking at the mineral fluorite, which has a hardness of 4. And this is gypsum, which has a hardness of 2. So I can take this fluorite mineral and easily scratch the surface of the gypsum. So this is a hardness 4, scratching a hardness of 2. On the other hand, this is quartz, which has a hardness of 7, and I can now scratch the surface of fluorite with the quartz. Now, Mohs hardness scale is still in use today. In fact, you'll be using it in your own lab. The relative hardness of any mineral can be determined by which minerals can scratch and which minerals can scratch it. However, it is not practical for someone to carry a mineral hardness testing kit that includes all 10 of Mohs minerals. A more convenient and practical solution of estimating hardness is to use a few testing minerals for which we already know the hardness. So one of the most convenient and available materials is your fingernail. Fingernail has a hardness of about 2.5. Copper penny has a hardness of about 3.5. Steel nail, hardness of about 5. Glass plate, hardness of about 5.5. And finally, a piece of porcelain street plate, which we'll be using in the lab, has a hardness of 6.5 to 7. Therefore, if I take a mineral, such as this one, and I can scratch it easily with my fingernail, that means that this mineral has a hardness of less than 2.5, which is the hardness of my fingernail. On the other hand, this particular mineral I'm unable to scratch with my fingernail, so it must have a hardness greater than 2.5. And if I take a glass plate and try to scratch that glass plate with this mineral, it won't scratch, which means it has a hardness less than the glass plate, which is 5.5. So by doing this, we can determine the range of hardness of this particular mineral, which is greater than 2.5 but less than 5.5. In this way, you can determine the hardness or the range of hardness for each of your mineral lab specimens. Along with cleavage and fracture, hardness is the most useful property for mineral identification. In the next hands-on video, we will examine the mineral properties of color, streak, and luster.